I intended to do a short piece on isotopes in my last video about ions, but my battery ran out of charge. So I'm going to do a little, very quick video now on what isotopes are. Isotopes are atoms that have got the same number of protons, they've got the same atomic number. So in this example here, chlorine has got an atomic number of 17. It's got 17 protons. The number of protons determines which element it is, so it must be chlorine. But they have a different mass number because they've got a different number of protons. So work out the number of neutrons by doing 37 take away 17, so 20 neutrons, and 35 take away 17, which is 18. So there's 18 neutrons in that isotope of chlorine. So the definition would be atoms with, or atoms of the same element, let's say, atoms of the same element, same number of protons, or you could say same atomic number if you like, and different numbers of neutrons, or you could simply say different mass numbers. Right, that's basically what you need to know about isotopes, and there's lots of examples of them that are quite common. So another one you might see is carbon 13 and carbon 14. Both have 6 protons. They're the same electronic structure, but they have different numbers of neutrons. Now isotopes have different masses, but there's no difference in the chemistry between them. So a chlorine 37 isotope behaves the same way as a chlorine 37 and 35 chlorine behave the same way as each other. Sometimes, as you might learn in physics, isotopes that you'll learn about can be radioactive and do interesting things. You'll learn about that in physics, so I'll keep away from that here. I'll remind you briefly now, though, that you do need to be able to work out something called the relative atomic mass, and that's the average mass of all of the isotopes of a particular element. And I've done a separate video on that, so I'm not going to spend very long on this at all. So all I'll say, just remind you of the definition: average mass of all isotopes of an element. And so the RAM, we calculate that by doing the mass number of one isotope times its percentage abundance, or times by its relative abundance, depending on what information you're given. Let's say it was 75. I'll do an example underneath. So the relative abundance, usually given as a percentage, you add that to the mass number of the other isotope times its relative abundance, all divided by that number, add that number. And if they're given as percentages, let's say it's 75 and 25, they're up to 100. That's usually what they do. Okay, so I'll leave that like that. So as an example then, if I had 2 isotopes of chlorine, I'll do this one here because you can see it. If I had 2 isotopes of carbon 13 and carbon 14, the more common one, by the way, is carbon 12. That's the one that is like 99% or something or more. So we can do it. We'll do it with 3. So it might be 99% of that one. Let's say 0.9% of that one, and 0.1% of that one. You do this number times this number, 12 times 99. Add this number times this number, add this times this. This will give you the weighted average, or weighted mean, if you like, of the different isotopes of carbon, and that would come to a number always between the 2 extreme masses. So, and it's going to be weighted heavily towards 12, so it'll be 12.01 or something like that, or 12.1, something very close to 12. But the number's always going to be within the range 12 to 14 there, okay? And that's that.